Good afternoon, sir.
Good afternoon. Should we wait for 5 minutes?
No, sir, you can start the class, sir, because they are joining in group only, sir.
Okay.
Yes.
All right. All right. Good afternoon, everyone. So as people start joining in, I think what we'll do today's topic is around project managers and how product managers and how technology can be used as a part of the product managers. So we will learn today what are the various fundamentals that is required for a product manager kind of a role. So in the classes, last classes, we had some sessions on generative AI. Today we'll look into the careers as a product manager. And again, in the future, we will look into the other careers options as well in terms of project management, in terms of agile, scrum, AI, machine learning, marketing, sales, etc. Right? So each one of these classes will talk about a certain attribution of how a technology or how or what are the fundamentals that is required for such careers. So tomorrow, if you are kind of looking at a growing certain career, or you want to be a product manager, you want to be a project manager, you want to be a marketing and sales manager, etc. These will come in kind of in handy, right? So today's topic is technology for product managers. So basically, we will learn about what kind of basic programming languages do you need, how the typically internet that works, the fundamentals, certain terminologies such as your SDKs and frameworks, etc. What is a database? What is an API? In to some extent, how do you what is web development, right? When we say web development, what is mobile development? Certain basics, version controls, and kind of release. Whenever a product is kind of rolled out, there are some kind of a version controls, and then there is review, and then there is release, right? So we will see these kind of fundamentals, and this may help you to think if this is a kind of career or a job in any organizations you may want to take, which is about product management. What are these fundamentals that might actually be helpful for you? So that is today's class all about, right? So just like any time, if there is any questions, if there is anything that you would want to kind of discuss, please feel free to raise your hand and speak, or put your questions in the chat. I'll be happy to kind of answer. And of course, we will have the videos being played. We will have those examples being showed, which I will kind of play right now. And then you will kind of go through these courses, and then we'll have certain interactions or certain notes which you will want to take, which I'll be kind of letting you know as we kind of progress, right? So I will share my screen. So my screen is now visible to you?
Yes, sir.
Okay, and I'll just play the video, just see if the sound is audible or not.
Product management. It's one of the most...
The sound is audible?
Yes, sir. It's audible, sir.
Okay, fantastic. So I will start from the beginning. Let's understand what is product management, and then what kind of technologies are required, what are the basics. Then we'll have some sort of a examples, etc., and we'll see how it goes, right? So let me play.
Product management. It's one of the most vague and misunderstood roles in the tech industry. But did you know that a huge number of current CEOs got their start as product managers? On top of that, nearly every founding CEO performs the role of product management, some more than others. Steve Jobs is one of the most well-known product CEOs in history. Product management is all about building the right product at the right time, so it's easily one of the most influential roles at any company. But it requires working with engineers and tech concepts that can be confusing to non-engineers. Even if you're not a product manager, understanding this stuff is going to put you at a huge advantage in your career. That's where this course comes in. I'm Cole Mercer, and I've been teaching product management for over 4 years to over 34,000 students. I've worked with major consumer companies like SoundCloud with hundreds of millions of users, as well as other major verticals like enterprise and e-commerce. In this course, I'll demystify basic technology concepts such as web and mobile development, all the way through more complex things like version control. Product manager or not, I hope you walk away with a ton of new knowledge that will help you in almost any modern career.
Again, very important thing to keep in mind, as the coach says here, that whether you want to be a product manager or not, but these are some basics which will be required in any career fields. If you want to become a complete product manager, then obviously all of these things are to be learned in detail. But even if you don't want to be a product manager, but you are going to be working with various product managers in your role, in your organization, then also knowing certain of these basics becomes important, because then you have a good conversation. Let's say, for example, you are working in marketing, but the engineers are working on building the product. The engineers might be good in the technical part of it, but as a marketeer, you need to be kind of feeding in what is the user experience, or what is it that is required to be built in the product, and hence this requires the marketing and product management team working hand in hand very closely, right? So in any of the career that you kind of take up in the future, knowing the essentials of product management is going to be critical. And this is what we will study in today's class over here, and we'll listen to this, right? There was a good example of, so in the video here, you will in the slide here, you will see that typically examples of if you're working in a web browser, in the URL, how does it working in the network and the DNS servers and the IP addresses, etc. And then how does typically what's the fundamental concept of product management is about building the right product at the right time, right? So then knowing the product management, knowing how things work in terms of technology and product management is something what we'll see, right? So let's listen.
Unless you've been living on a remote island somewhere in the Pacific, you've probably heard a lot about cloud computing or cloud-based applications. The cloud is just an invention of marketers who realized that over the internet didn't sound techy enough to get you to spend lots of money. So they came up with this term, the cloud. It's just another name for the internet. So now let's get to the basics of how the internet works. The internet is a lot of devices connect together in a huge network. If we want to connect our devices to this network,
so basically here we are learning about cloud, and then in simple language, how does this work?
That is computers, phones, thermostats, etc. We need to go through an ISP, an internet service provider. The ISP provides you with a portal into this network, and they charge you monthly for this service. The devices on the internet can be sorted into two different classes, servers and clients. A server is a machine that stores data and allows others to access this data. A client is any device that you use to access a server. So this could be a laptop, a smartphone, or an internet-connected device like a printer, or even these days a refrigerator. When you go to a website or use any online service, you're really connecting to a server that provides data in the form of a web page or a service like email. These servers have an address so they can be found, just as you and your friends have addresses and phone numbers so you can contact or visit each other. The address of an internet server, called the IP address, is a series of numbers that is not easy for us humans to remember. Web servers also have a human-friendly address called the URL. Google.com or any .com or any .anything address is a URL. These are easy to remember, but they are not a real address. A URL is like your friend's name. It identifies them, but it doesn't tell you where they are or how to contact them. Luckily, when we do go to a website, we don't have to get out some sort of address book to find the IP address. The internet provides an automatic address book called DNS, the Domain Name System. DNS translates the easy URL like google.com into the IP address so your computer can access Google web servers. Here's how it works. When you type the URL into your web browser, your computer sends a request through your connection to your ISP, through their network to a DNS server. The DNS server then returns the IP address to your web browser, and now you can communicate directly with the web server. Your requests for information are sent through your ISP to the website, and then the website returns the information to you over that same path. So there we have it, a short and sweet guide to the basics of the internet, and I even got you some insider knowledge on buzzwords like the cloud. If you have a decent understanding of what we've discussed in this video, you are miles ahead of most folks working in non-technical roles in the industry. Use this newfound knowledge to your advantage.
So essentially, we just learned in a very basic way, what is a server, how does the internet work, what are the ISPs and DNS, etc. What is who is the definitions, right? The reason why we learned this is because in a product, for a product manager in any organization who is using a technology or is dependent or is reliant on technology to kind of build the product or even take the product out in the market, these basics and fundamentals are something which is very important, and hence we are kind of learning about what these things are, right? So it might be very basic terminologies, but these are very important concepts to keep in mind, and only then we learn about we will see how we can use these knowledge to build some product later in the course, right? So next we'll learn about the front end, back end, and tech stacks, the various tech stacks that is required, because any product that you build using a technology, you will have to deploy the product, and for deploying the product you will need all these tech stacks and various other things, right? So let's listen to that.
There are a lot of terms to keep track of in modern day tech companies, and most of them don't have to be as hard as they sound. In this movie, let's go through a few of them: front end, back end, application layer, and tech stacks. The front end simply means what the user sees and interacts with: the text, colors, layout, and buttons that you see, read, and press in a given software program. Now, on websites, the front end is usually programmed with languages like HTML, CSS, and JavaScript. Don't worry too much about the specifics of those right now, though. The back end refers to the servers and databases that hold the information. The backend uses technologies such as MySQL, a database language, and usually a hosting technology like Amazon S3, for example. The QL in MySQL, spelled MySQL, means query language. This is a language we use to ask a database to give us specific information. Amazon S3 is one of the ways that we can rent a server on the internet that houses our data and web pages and serves the data out to the public. Okay, great. We now have front end and back end down, but you might be wondering, how does the front end get the data? How does the back end know what to send the front end? Well, that's where application layer comes in. The application layer refers to the programming that does calculations and communicates between the front end and the back end, ensuring that the right data gets to the right place. The application layer acts as a go-between, linking the front end and the back ends. You might think that the application layer code is located in some other place, but the code for the application layer is housed on either the front end or back end, depending on how a particular application is programmed. Let's say that you go to a site like Amazon and search for a product from lowest to highest price. This application layer reads this search, queries the database for the products you want, and then sorts them into the correct order so that the front end can display the results in your browser. The application layer uses languages like Python, PHP, Ruby, Scala, and many others. Now we can figure out what a tech stack is. That's easy. It just means all the programming and technology that makes up an app or website, all the way from the front end to the back end.
Okay, so very simple definition of what is a tech stack, right? Various technology and you stacking them up. The programming that makes up an app or a website, which is the product development in terms of the product manager's roles when we are talking about. So simple thing to keep in mind. What is a tech stack is it's the programming that makes up for an app or a website, and there are various types how it is being used: front end, back end, in terms of receiving the query, getting that searching in the database, coming up in the front end in terms of the output, and all of this together kind of makes it for a tech stack. But just to keep in mind, a simple definition of tech stack is the programming that makes up an app or website in this case.
Different apps or services will use different languages or technology because each technology or language has advantages over others.
Important thing to keep in mind, while we are building the apps and using the tech stack, etc. Each one of them may have a different language, right? Somebody may use Python, somebody may use something else, because each language has certain advantages and benefits, and that is what the author is kind of talking about here.
For certain types of applications. If we make an analogy to buildings, the tech stack would be like describing the materials and building techniques that are used to build them. A skyscraper requires way different materials and techniques than a single-family home. The examples I used here relate to a web browser on a laptop or desktop computer, but the ideas are the same for mobile devices. It's just that the technology used is a bit different. For example, instead of using HTML and CSS like in a web browser, a mobile app would use a language like Swift for iPhones or Java for Android devices. So there we have a quick and easy explanation of these terms that I guarantee you'll hear frequently while working in any technology company. Almost everything you see in technology is comprised of these things, so keeping this in mind is vital to learning more about technology in the future.
So now we'll learn about what are the various programming language that can be used. The various simple programming languages that are used to build in the tech stacks, and then finally all of these are used to build the product.
As a product manager, you'll hear software engineers and others talk about programming languages. And if you hear a couple of them talking details with each other, it could really sound like a foreign language. But you don't have to speak the language to understand the broad concepts and general ideas. It's really pretty easy, so let's get into it and see. A programming language is simply a way to give instructions to any kind of computer, including a phone, so that it accomplishes a certain function or provides a certain experience to someone using the device. A complete set of instructions is what we call an application, or app, or program. You'll also hear the set of instructions referred to as the code. Code just means the instructions that are written in the actual computer language. Computer languages differ in the specific types of functions they do well. Let's look at a few and see. If you're working with web products, the languages used there are HTML, CSS, and JavaScript. You can think of them like this. HTML provides the content you see on a web page, basically what the text and images are. CSS specifies how that content should look, what font and what size, the background color, and all the visual aspects of a page. JavaScript gives the web page behavior. If you interact with a web page and it responds to you appropriately, JavaScript is probably responsible. Python is an example of a high-level language. This just means that Python is often used to program web servers and mobile apps. Python programs are often called scripts, and the language itself is frequently referred to as a scripting language. You're probably going to hear about Python the most in reference to data analysis, as it's a very popular language to make scripts in that parse data. Now, Java might be confusing because it sounds similar to JavaScript, but they aren't even close. JavaScript is specialized to change the behavior of web pages, but Java is an all-purpose general programming language that is used to write everything from enterprise software to games and mobile apps. Java is designed so that once the program is written, it can run on pretty much any platform that supports it without any adjustment to the code. Objective-C and Swift are the languages that power Apple's iOS and OS X. They are used to write apps for the iPhone, and for that reason are very popular languages for developers who want to tap into this lucrative market. Ruby is another language that is pretty easy to read and, like Python, is considered to be a good, user-friendly language for beginners. It's used for developing websites and mobile apps and is the power behind sites such as Groupon and Shopify. You've probably heard of Ruby when people talk about Ruby on Rails, which is just a framework that makes building applications in Ruby even easier. Scala is what's called a functional application language and was designed as an update or improvement to Java, providing features or fixing things that Java does not do so well. Programs written in Scala are compatible with Java, and they will run on any system which can run Java, which is just about anything and everything. So Scala, like Java, can be used to write a wide range of applications. Finally, we'll end up with PHP. PHP is a web server language that is used to display pages on websites and mobile apps. It generates web pages that are created on the fly based on a user's request or input. You'll often see .php web pages in the address bar of your browser. PHP was one of the earliest languages adopted en masse for making full web applications. So that sounds like a lot to take in, but don't worry, you don't have to be an expert. Just becoming familiar with a few of these terms will ensure that the next time you're involved in a conversation about programming, it's not going to sound so much like a foreign language.
Yes, the last part of this is important, that you cannot be an expert or you are expected to be an expert in all these programming languages. But what you need to do is you need to know the names. Like, you need to be familiar with, okay, there is something called Java, there is something called PHP, there is something called Python and Ruby, etc. Unless, of course, you are a technical person yourself. Now, what happens is, say, for example, you are a non-technical person and you are working in an organization and with a product development team, right? Taking the same example of a marketing, if you are working in a marketing, then you will have to kind of work very closely with the product development team and give them the business scenarios, the use cases, etc. Now, let's say the product development team is using a Java as a program, or they're using Python as a program, or they are using a Ruby as a program, etc. They can use anything depending on what that organization's tech stack is. What is it that an organization wants to kind of build the things into, right? So as a marketing person, you are not an expert in Python or a Java or a Ruby, but you can always recommend, you can always tell, or you can always have a discussion as to, oh, I see this web page is getting built. Are you using PHP? Okay, fine. What is the merit of a PHP? All right. Or if you're using a PHP, there can be a drawback. So I think those are conversations as a non-technical person you may want to have with your product team or your product managers or your technical team. And hence it is important to know what kind of various options or various programming languages are available. On top of that, if you are able to kind of, learn a little bit more about anything specific, that's absolutely fine. But the essence of this course today is to understand that, what is available and how do we smartly have those conversations with the relevant team members so that, you don't feel like you don't know anything when you're working in an organization. You at least know the terms and you are kind of, going and working with the product managers and asking them the right questions and building the things, that's all, right? So that's the idea. So it's not about I need to know all the technology, but I do definitely need to know the names of the technologies which can kind of help me to have those kind of conversations. I think that's important, right? So let's listen to the other additional terminologies, like what is an SDK, or what is a framework, or what do we mean by a library, right? What is a database? What is an API? All these things is something what we need to know in terms of our terminologies and understandings. So let's listen.
Alongside programming languages themselves, developers use a few tools to help increase efficiency when they code, or that allow them to code for certain platforms. I'm going to go over some terms that you might hear regularly in association with programming. Some of them have scary sounding names, but we'll see that they're really pretty easy to figure out. Let's start with libraries. A library is a collection of code you can have alongside your application so that your app can link to it and use that code. It's a file with a bunch of reusable code so that you don't have to write the same code over and over again. Some people make libraries others can use freely for pretty common calculations, or chunks of code a programmer would need on a regular basis. An example could be a library of statistical functions or algorithms a programmer can use in their own program without having to write that code again themselves. Ever have a phone number that you put on speed dial instead of dialing it all the time? Think of a library like speed dial for programmers. Now let's talk about frameworks. A framework can be anything or everything you use in an application development. It can be a single library, a collection of several, or even a bundle of something else like scripts. If you're wondering what the difference is between a framework and a library, you're not alone. Here's the key difference. Frameworks are just larger sets of pre-made code with blank areas that you fill with your own code. Now, libraries, on the other hand, are smaller, more narrowly focused pieces of code that you could use in your own larger code that makes up your program. Here's a quick real-world parallel. Imagine you're designing a house, and you find your ideal location and design your own outside walls, roof, etc. But you want to design 2 of the rooms in your house the exact same as the rooms your friend's house has. But you don't want to do the work of trying to replicate that design into the blueprint yourself. So you just get a copy of those room designs from your friend. In this case, those room designs you got a copy of are like libraries. On the other hand, if you went to a store and bought an entirely pre-made design for your house, with one blank spot for a room you could design yourself, that'd be more like using a framework. All right, another term, SDK. An SDK is a software development kit, or a set of tools for creating apps using a particular programming language. An SDK is usually centered around an application where the actual coding and testing takes place. The SDK is like the programmer's workshop, where they have all the tools and resources they need to build an app. For example, if a developer wants to make an app for iPhones, they need to use the tools inside the iOS SDK, which is provided by Apple, to make their code work on an iPhone. So keep these in mind, and you've got a good foundation for the most common terms you'll hear engineers use in association with programming languages.
Now, another example, what we can talk about here is in, say, for example, the SDK, right? And I'll take the example of a marketing person again. Now, let's say as a marketeer, or let's say as a digital marketeer, you may want to advertise on a platform, let's say Facebook or on Instagram. Now, in order to track whether you're getting the right data, and from your marketing activities you're able to track the information, if your ads have to appear in a particular app, right? If you're targeting certain apps where you'll be wanting to see whether your ads are going there or not, you will have to insert a tracking code as a part of the SDK. So as a marketing manager, as a marketing person, you will be telling your product development team that, hey, you know what, I would need this tracking code to be used. And the product manager or the technical or the engineering team is going to build it for you, right? So again, does this mean that you are an SDK expert? No, you're not as a marketeer. But do you know what the SDK means? Yes, I do. And then hence I'm able to go and tell the engineers that this is exactly how it needs to be done. That we need to kind of place this code, and so that we get the tracking information. So that's important, and that's precisely what this course is teaching, in terms of what those terminologies are, what are those frequently used common terms, etc. Right? So let's hear more in terms of what is a database and what are APIs.
Understanding how data is stored and retrieved will be vital as a product manager. Let's take a look at and demystify the storage centers of information, databases. A database is nothing more than a way to store information in a manner that makes it easy to search and retrieve it when needed. It's similar to a spreadsheet, except in a database, there's no redundancy. Here's an example. Suppose you have a list of contacts and several of them work at the same company. If you manage this in a simple list or a spreadsheet, you'd repeat the same company and address for each contact on your list. Now, with a database, you simply note that they work at company X, and the database then pulls the address from another table that contains the addresses for the companies that you're dealing with. The address is only entered and stored once in the system. Of course, this doesn't amount to much savings for a small personal address list, but in a company that has millions of customers, the benefits are clear. There are two common types of databases out there, relational and non-relational. Relational databases are an old, proven, and reliable method for heavy data analysis when complex searches are needed to find information. In some applications, such as, let's say, banking, this is a really big deal. A person always has to be linked to the correct account information, and a reliable technology is vital for that type of industry. Now, the other type of database, non-relational, sometimes referred to as NoSQL or NoSQL. These types store information in specialized documents in a way that is not easily visualized and without highly structured links. They're best for situations where a traditional relational database can break down or fail to keep up with rapidly expanding amounts of data. This is because, although they don't enforce relations as well, they handle huge amounts of complex data easily. Non-relational databases are more recent and specifically take advantage of the vast cloud storage capacities available today. Their advantage is the ability to easily scale across many servers with rapidly increasing data loads. Names you'll hear that refer to relational databases are the several varieties of basic SQL, which stands for Structured Query Language. MySQL, or MySQL, is just a more portable and open source version of SQL, and is very widely used in databases for e-commerce and the content management systems around the world. In the non-relational database world, a couple of names you'll hear are Cassandra and MongoDB. Cassandra is open source and was originally developed by Facebook engineers, and it's used at companies like Netflix. MongoDB is another open source NoSQL database and is used by many large sites such as Expedia. Keep these concepts in mind, but don't worry about diving too deep. If you understand the basics behind how data is stored, you've got a big leg up in productivity and influence with your teams when it comes to discussion on building products. One term you may hear more than any other in modern tech is API. API stands for Application Programming Interface. Though it may sound complex, it's really not. Let's talk about how it works. An API is just a way for one program to get information from another program. It acts like a messenger between programs. An API takes a request in a program you're using to another program that can fulfill that request. It tells the other program what you want, gets the information, and returns it to the program you're using. In many cases, that other program is a database with the information that you want. Let's say you're in a store and you see an item you want on display. You want to know if it's in stock, so you find a salesperson. The salesperson accesses a database, finds out, and lets you know. The salesperson is like an API because they took a request, had access to the database, and knew how to get information from it, and they finally brought it back to you. Now, there are two kinds of APIs, public and private. Companies provide public APIs to allow other companies' services to get data from them. One example is a travel service, such as Expedia. If you go there to look for a hotel, their website then accesses the public APIs of every hotel company and returns the rooms available for the place and time you specified. Now, Expedia doesn't have that information itself. They just use the public APIs of the hotel companies to get the information. Then they give it back to you for comparison. Many companies have public APIs so that developers can build products that use their information. A private API is, you guessed it, an API that is restricted to developers inside of the company. These companies are big and they have information stored on many databases across the enterprise. Twitter, for example, probably has different databases with tweet text, images, etc. If a developer on one team is building a feature that needs information from somewhere else in the system, they'll write a request, known as an API call, into their code. This request goes to a location in the other database called an endpoint. It's kind of like a service window where someone is waiting to take an order. The database fulfills the request and sends the information back to the program where the developer requested it. One other thing to note here is that APIs might have restrictions that prevent problems on the system. For example, they may limit the number of requests allowed per minute so that the system doesn't get overloaded. Or they may limit the type of data you're allowed to get back. This is especially true with public APIs. Otherwise, any random person could spam any company's systems with millions of requests and cause an outage. So that was pretty easy, wasn't it? An API is just there to allow developers to write code in their program that gets data from other systems. Now you're armed with detailed knowledge on a term I guarantee you'll hear almost daily in any technology-focused company.
Okay. So while we have learned all these basics in terms of what is an API, what is a database, what's an SDK, programming languages, etc., we will see a use case of how a product development team in an organization is going to talk about web development and then about mobile development. These are the two most common examples that you will keep hearing in the industry or any organizations that you work for, etc., and listen, right? So that's going to be useful. So we will hear what this means and what is a desktop versus a mobile, what is how do you create a website and content management systems, etc. And then again, the basics of mobile development, what is a native and a non-native and hybrid apps. So these are examples which is very, very common in an industry. And a lot of the product development teams actually use technologies in the organizations to kind of create this, right? So let's hear about them.
The biggest marketing trend in the digital age is the almost overnight and meteoric rise in the use of phones and tablets on the internet. People now use their phones to search for and buy the things they want or need. It's vital that users get the best experience on a website no matter which device they use, a laptop, phone, or even a tablet. This has led to the rise of a marketing buzzword, the mobile UX, or mobile user experience. Since all of these devices have different characteristics, how does it all play out when it comes to the technology used in developing websites in the modern day? It's pretty simple. The key is in understanding how the experience a person has on the web changes when they move from using a desktop or laptop computer to using a phone or tablet. Here are some key differences. First, there's no mouse. There's no way to right-click for options when you see something you like. However, you can swipe and scroll and easily change the size of the content with pinch gestures. Next, the screen is much smaller, and simply shrinking an image often won't work. A chair might look great in a room setting on desktop, but shrink that picture to phone size and the image of the product becomes tiny. It might be that just a different picture showing the product you're selling is needed for a phone. Finally, mobile devices have much smaller memory and lower processor power than a desktop, and this makes it harder to show complex things like photos and videos. Now, how about the technology used to solve these problems? Well, when you're on any device and connecting to a web server, the data stream that goes to the web server includes information about the operating system, browser, and device type. This basically means the website knows what device it's talking to in terms of brand, model, and related things like screen size. Armed with this information, there are two strategies that people use to develop sites that are optimized for the device it's being viewed on. The first is to use a fully separate mobile site. This is where the server is programmed so that when it detects a phone, it sends it to a separate mobile-friendly site. That site will have text, images, and design specifically for a small screen. This is usually called having an m.dot site because the website it sends the phone to is m.whateversite.com. The method is one of the earlier ways of making websites and isn't really used much anymore because it basically requires that the engineers build and maintain two separate websites and code bases. Ever get a friend that sends you a link from their phone that looks all big and weird when you open it on your laptop? It was probably because they sent you the link to that separate m.dot mobile site. The other, more modern and increasingly common way of solving for different device types is what's called a responsive site, a single design that responds to the device type by changing the content size or actually changing the design for smaller screens. This can be done in the CSS code by setting what are called breakpoints. Breakpoints adjust the size and position of elements on the screen based on the width of the screen. This method may limit how complex your designs can get, but it's much faster and easier to maintain. If you want to see this effect in action, try pulling up a website on your laptop and resizing the window to be much smaller. If the text, buttons, and images move around to fit that smaller size, it's responsive. So there's your simple guide to websites built for the mobile revolution. Though you'll run into a lot more native development on mobile devices these days, mobile web is still something you need to be confident about no matter which business you're in. In this video, let's talk about a term you're likely to hear in any discussions about websites or business systems, CMS. A CMS is a content management system, and they're used for a variety of things. Let's dig in and see what this is all about. Just like it sounds, a content management system is a software that's used to design and manage content on a website. Have you ever heard of someone getting a website built by a developer, but when they want to make a change, like text or pictures, they had to hire a developer again to do it in the code? Well, if that site were built with a CMS in it, the content would have been stored in a system with an easy-to-use interface, where it would be easily found, published, modified, and reused. A CMS allows a person who is not a programmer or designer to publish or change content quickly. This works because the content goes into predefined templates that maintain the site's design, while still taking care of details, like how well the content will be found in web searches. This allows a company to be nimble in adapting to its website's ever-changing needs. The CMS is usually browser-based so that you can work on the site from anywhere, from any device with an internet connection. Content management systems just started out as content editors and organizers, for instance, as something to put into a website being built to let people easily edit the blog. But nowadays, a CMS can build entire websites. Ever heard of WordPress? That's a great example of a modern CMS. To appreciate what they do for us, let's look back at how sites were made originally. First, someone who knew HTML really well had to sit down and code the entire content and appearance of the site into documents that would become the web pages. Then the company would have to secure hosting services and tie that web server to where they had their domain hosted. This allows people to connect to the site. Finally, all of the documents would be uploaded to the site where they would be doing lots of testing and fixing, and then finally the site would be live. If you needed to add new content, that had to be coded by the HTML programmer, uploaded, and the changes made throughout the site to connect the new content to the existing pages. Does it sound complicated? It sure was. Now, there are services that let people do the hosting and content management all in one step and from one place. Some of these services even have an interface where you can drag and drop text and media into place on your screen, which it then translates into web code, resulting in something totally custom. Squarespace and Wix are good examples, as they're commonly referred to as WYSIWYG development because what you see is what you get. However, by far the most popular CMS these days is WordPress. Though it's not as drag and drop friendly as the others, it has grown so much that there are thousands of plugins available that can make your site do anything from basic blogging to advanced user logins and order tracking for web stores. So there we have it. There are various content management systems that design a site and create templates to easily publish content without detailed technical expertise. Keeping this in mind is one way you can reduce or remove the need for engineers if you're only needing a simple web application.
All right. Important thing to keep in mind in terms of the CMSs, like, as we talked about, what is WordPress, for example, is something which is very commonly used, right? So even it is so commonly used that even if you take a very basic understanding of logging into the backend and dragging, dropping, and changing the content, etc., even you can probably also play around with a WordPress kind of a site to build a web page, right? But I think the important thing to keep in mind in this entire chapter was desktop and mobile web. What are the various technologies required, used? The CMS, what are the various CMSs that is kind of available, etc. Which having a knowledge is helpful because this helps to have those conversations when one is building this, or when you're working with the technical team, when you're working with the product team, right? So let's now look into the mobile development and basics of the mobile development and how it kind of typically works. Let's listen to this.
The rise of smartphones has made Android and iOS household words. I guarantee you'll hear about them mentioned in your work as a product manager, so it's really important to understand more about them and what makes them so different. That said, let's dig in. Android and iOS are operating systems. An operating system is a central control of your device. It runs behind every app, connecting the app to the basic functions of the phone, such as the camera, the GPS, and yes, even the telephone. The operating system serves the same function on a phone that Windows or OS X serves on your laptop or desktop machine. The main difference here is in who makes them and which phones they support. Apple makes the iPhone and iPad, and iOS is the operating system they provide to run these devices. Apple controls what goes into iOS because they make both the phone software and hardware. This means the base features on any iPhone running the same version of iOS are virtually identical, and that different devices running iOS will interact smoothly with each other. The situation with Android is a bit different. Android was created by Google and it's open source, which means it's available to anyone to use. That includes any company that manufactures smartphones. Now, Google does make some phones themselves, but the most common situation you're going to see is that an Android device has the Android operating system running on a phone or tablet, which is made by some other company like Samsung or LG. Now, since Android is open source, some of these companies also modify Android to add their own apps and features. This means that two phones running the same version of Android could potentially look really different. Unless the devices came from the same manufacturer, the fact that they both run Android doesn't necessarily mean that they're going to work well together or even have the same features. Now, you should also know that the systems and languages used to develop apps for each operating system are completely different. On Apple devices, there's Objective-C and Swift, which are the computer languages used for developing iOS apps, and most work is done through the developer network. On the other hand, Android apps are developed with several languages that are independent of Google. The official development language is Java, but C++, C#, and Python can also be used in some cases. The apps for these devices are distributed by stores controlled by Apple or Google. Now, Apple exerts a lot more control over the apps that are approved for their store, effectively meaning they control the app development process much more. Getting that app approved for the Apple App Store can take up a lot of time, but the approval process for Google is a little bit easier. However, they still do have strict standards. One consequence of having multiple phone manufacturers is fragmentation. Each manufacturer's phone is essentially a different platform, even if the Android version is the same. So this problem, along with lower profit margins on Android, offsets the greater ease of getting the app approved. One other thing to know about Android phones is that, unlike iPhones, in many instances you can install basically whatever software you want on the phone, even if it doesn't come from the App Store. This isn't really a wise move for security reasons, but some tinkerer types like developers like having this option. In order to do the same thing on an iPhone, you need to go through this really complex and risky process known as rooting the phone to subvert the security protocols Apple has put in place. Now you've got a good overview of the most common concepts you're going to hear in relation to making applications on mobile devices. In the modern tech industry, this knowledge you'll use basically every day. And it's also vital stuff to help you understand future technological advancements as they happen down the road.
The key takeaway here is Android being an open source and iOS being not. And then because it's an open source and it was originally developed by Google, while Android is from Google, but the manufacturers of the Android phones there are multiple players in the market, like Samsung or Oppo or anything for that matter. There are multiple such players, right? Whereas Apple is just iOS and Apple. Hence, the security is much more higher in Apple. To build an app and get that app listed on iOS is definitely a much more stringent processes. And the important part of using an iPhone and an Apple is the consistency, because it is just one manufacturer, that is Apple, who is building the Apple phone, and not multiple mobile phone manufacturers who are using Android to build the smartphones, right? So these are the few very basic concepts of the mobile development. And it's important to know this because even in the digital world, whether you are doing a marketing or whether you're doing a promotion, etc., is very important how you are creating a strategy to be promoted on an Android device or on an Apple device. Your advertisements or your creatives, etc., is going to be dependent on that. Even the way you say, for example, apps like Facebook or Instagrams, etc., they appear on your mobile device, and the way your ads, etc., or your marketing is going to be done is also something which is very dependent on which device you are using, right? For example, getting information, user information from an Android phone is much more easier, and hence you can target those users accordingly. But that may not be possible in an Apple unless the user gives the permission while downloading the app. So these are various things to keep in mind, and hence a conversation around product development, around technology, and for this is important. Now let's hear a little bit more about mobile development in terms of what is a native and what is a non-native and what is a hybrid app. I think these are terminologies which is also important to keep in mind.
Advancements in technology happen every day, but one category of technological advancement is less visible to the average person, yet has a huge impact on the industry and product management. I'm talking about developer tools and environments, which is really just fancy speak for things that engineers use to do things better or faster. So why are these improvements in these tools important? Well, whenever there's speed and quality advancements in the ways developers can do the work, it has a secondary effect of making other technology and your company's product advance more quickly as well. To understand the latest in mobile development, you'll need to understand how developer tools have changed. Specifically, I'll tell you about 3 older, more common ways, plus one new way developers are making mobile apps. Years ago, you could only make an Android or iOS app by coding them using the appropriate language, Objective-C for iOS and Java for Android. So you would need someone in your team with each of these skills, and any changes you made would have to be sent to the App Store where you'd wait for your users to update their apps to get your changes. This is what's referred to as a true native app. Native because it's made using the native programming language on the operating system it runs on. Given the expense of that method, many people opted to just make mobile version of their website. But since it was just a website using web languages, it wasn't available in the app stores, and it was harder to do fancy mobile graphics and interactions. Years later, tools for developers allowed them to wrap any website code into a native frame and turn finger interactions into mouse clicks that worked effectively with a typical website. That meant you could relatively easily put a real app in the App Store, which would just render your website like a normal browser would. However, you couldn't integrate with the phone hardware, like cameras or sensors. This is referred to as a web view application because it's displaying things just like a web browser. Later on, some developers created ways to combine the techniques further and display less complex screens or parts of apps with web languages like a web view, but then other more complex parts of the application with actual native code. This is referred to as a hybrid app or view. Recently, new frameworks have made it possible for someone that knows a common web language to make a fully native app for both iOS and Android nearly simultaneously. What makes this so exciting is that many engineers with little mobile experience have been able to write code in a language they've used for years that results in a fully native application on both iOS and Android. Although it's quite new and still not as powerful as coding natively, developer technologies like React Native are currently and will continue to change the way we develop applications. As a product manager, it's important to consider these sorts of recent advancements to determine the best way to build a product with your team. To sum it up, just remember that there's often more than one way to make a mobile application. You might only need a mobile website, but if you do want to go into the app stores eventually, there's a variety of options depending on the skills of the developers you're working with, as well as the technology that's available to them.
All right, now let's we have gone through mobile development and web
One
development.
important concept.
Let's now go through what are various version controls, right? Now all that we do ultimately when the product is released, and whatever these products are, you will always see a version 1.1 or version 1.2 or a version 1.3, and there are various enhancements that happen in the life cycle of a product development, and these are nothing but is called as the version controls. In this case, we will see what is a version control, what is a repository, and how do you ensure those data is stored, etc. What is a staging, what is a production, final production. Staging is basically an environment where you will get to see before it goes live, right? And then the various releases and the versions, etc. Right? So let's listen to the version control examples.
The concept you'll encounter as a product manager is version control. And part of that is complicated sounding jargon like Git and GitHub. But really, these aren't so complicated at all. Let's dive in and have a look. Version control is the ability to manage changes in content and configuration of a product, most often a software application. You can probably think about this with your own work. Say you're writing a detailed report over a few days. As it progresses, you make changes and overwrite old content. Later, you decide that some of that earlier content was really good, but you deleted it and overwrote it in your working version. Well, hopefully you have a really good backup strategy and get that older version with the original content. This is a simple example where keeping and managing versions may have been helpful. But now let's magnify the problem. Now it's not a written report, but a huge software development project, and there are a lot of developers working on it. Now there's a lot of potential for mass confusion with inconsistent file names, uncertainty about the current version, and developers accidentally overwriting someone else's work or duplicating effort. Version control is a way to solve these issues. The original version control system was called CVS, which stands for Concurrent Versioning System. Subversion, or SVN, came along in 2000 and is still widely used today. These systems kept a single main copy of a project in a central repository, a main stash of all the files where all workers pulled a copy to work on and then submitted changes back, which were checked for conflicts with other changes and then finally recorded. SVN systems are pretty slow. Today, not only do large teams work on projects, but these teams may be located around the globe. The latest and most popular incarnation of version control is called Git. Originally made in 2005, it's definitely the most popular version control system out there. Git is a big advancement because it's what's referred to as distributed version control. Along with a central repository, now there are multiple repositories located near the workers. Each worker works from that local repository and later submits changes to the central one. Distributed version control systems such as Git speed up development time a lot. You've probably also heard of a thing called GitHub. GitHub is a company that essentially just took Git, hosted it online, and made it really easy to create and manage repositories through the web. Developers can easily share their code with team members securely and globally without setting up their own servers. They can invite others to contribute and manage just about everything with a nice web interface instead of a complex text-only terminal. Others have used GitHub to make their project repository public, also known as making them open source. This allows the general public to search for and contribute to coding projects that they're interested in. If you hear someone saying that something is open source or that they're contributing to open source software, it's likely that they're doing this through GitHub. All right, so that's it. Version control is just software that's used to keep track of changes and manage a large project that has many contributors. It's highly likely that you'll be using Git or GitHub at a modern organization, but understanding how and why it all works is key to engaging with technical folks in your day-to-day work.
Again, a very important recommendation in the end. You may not be using GitHub yourself, but your technology team might be kind of using it. And GitHub is extremely popular in the industry. Like, you ask any technology organizations or any technologists, they will know about GitHubs. And GitHub is nothing but where you are able to share the various version control and the codes, etc. With your the tech counterparts in the industry, right? So it's important for you to understand that if anybody is using the term GitHub or a Git, what does this mean, and then how can it probably, where you can kind of contribute more towards it in the conversation, right? That was the the main intention of this kind of version control thing. Let's hear about what are repositories and what is a forking or a pull request. These terminologies and what does these terminologies mean?
Version control is an important topic. It all starts with repositories. Repositories are the main stash of code and documents for a project. They can be centralized, where there's just one copy, or distributed, where there are many copies of the main repository distributed around the globe for productivity. As you can imagine, having multiple copies of the repository introduces complications. As such, a whole vocabulary has arisen to describe working with a distributed repository like Git. Let's see how this works. Suppose you start working on a project. You begin by downloading a copy of the repository from GitHub to your computer. The repository contains all of the files in the project. Once you've downloaded the repository, you create a working copy of those files on your local machine. The working copy is called a branch in Git terms, and it's what you make your changes in. Think of it like you're downloading a Word document from the internet that you want to change. Instead of editing the original file, you duplicate it with a new name. This way you can always go back to the original if you need to. Now, back in coding land, after you develop a sweet new feature, you commit those changes to your local working copy. However, while you perform this work, the main project might have had changes made to it by another developer to do something like fix a bug. In order to ensure your working copy has these latest changes, you can pull or download the latest changes from GitHub into your working copy so that it remains up to date. So you may hear others talking about branching, committing, or pulling, but it's all really just a fancy way to say you're downloading the latest code onto your computer, creating a working copy of it, doing some work, and sometimes checking to see if anything was updated while you did your work.
A very, very important thing to remember, it is nothing but downloading the latest code and ensuring that the latest work that you are doing, when I say you, I mean the engineer or the product team is kind of doing, and it is as refreshed and latest as possible, right? So it's a two-way process. It's all stored in the repository. From there, if there is a new code, etc., that is available, you kind of download it, and then you kind of see, make your edits and your work, etc. And then that's how the system kind of typically works. So it's an ongoing system. But essentially, it means downloading the code.
But wait, you may remember that this repository we're talking about is a local copy. That means there's still a central repository out there. So what happens if you're done making changes locally and want to upload them to that central repository on GitHub? This is exactly what the push command is for. It uploads your working copy to GitHub. However, for many projects, pushing your working copy to GitHub will not immediately change the main project. First, your new code must be reviewed by your teammates. In order to ask your teammates for a review, you create what's called a pull request, which is often shortened to PR. This is a page on GitHub that allows your teammates to review the changes you've made and make suggestions for improvement before it's committed to the main codebase. Once everyone is happy with your changes, you can use the merge command to merge your changes into the main project. After that, the next time your teammates pull or download the latest code, they'll get your changes. Lastly, you should be familiar with the term fork. This just means make a copy of and is often used in the open source community. If someone made some code that does task A, but you think it can be easily modified to do task B, you'd fork it, and it takes on a life of its own in a brand new repository owned by you. This all may sound confusing, but don't worry, you don't need to master it. Just become familiar with the ideas behind version control and what each term means. I promise you'll be way ahead of the game if you know the basics. In many tech companies, including some places I've worked, having a bug or an issue in the code that's seen by the general public can be a massive problem. At large companies like Google or Facebook, for instance, having users experience no service or even small bugs for just seconds or minutes could result in literally millions of dollars in lost revenue. Even if you work with the best developers in the world who never make mistakes in the code they write, with larger companies, there's potentially upwards of 10 to 50 developers working on the same areas in the code at the exact same time, which can make it almost impossible to judge whether something is bug-free. Using a version control technology like Git, developers download and then make changes to the most current version of a code base. Then they upload their changes to be compared with the changes that others have made in the same time span and resolve any conflicts in the code that come up. Sometimes, things look fine at first glance of the combined code. Yet problems are discovered when all of that code is compiled and tested hands-on as the end product, like a functioning website or a mobile app. So it should come as no surprise that in modern programming for web and mobile applications, no matter the size of the team, there's several safeguards to ensure the final product visible to the end users is as bug-free as possible. The first safeguard is version control, ensuring the code changes made by everyone appear not to interfere with each other. Typically, the place the engineers put their code after changing it to check for conflicts is something called a staging branch or integration branch. Then, the next test of the code is to see if it would actually run together in a real-world scenario. So it's run as a whole program in what's usually called a staging environment, which has all of that staging branch code run together into an actual usable form, whether that's a testable website or version of the mobile app. In the staging environment, people like product managers, engineers, designers, and QA engineers can do various quality assurance tests on the compiled code in special, internal, non-public environments to make sure everything works like it should. We click buttons, we try new features, enter data, and generally mess around, make sure everything looks really solid. Once something has passed the rigorous testing, it's then put into the next tier, the main branch. The main branch or server is exactly what it sounds like. The most complete and demonstrably working copy of the codebase. Once there in the main branch, the code sits and waits to be moved or deployed, in engineer lingo, to the most important server of all, the production server.
So again, very critical information to keep in mind. A lot of times you will hear in the organizations, like from the staging, when is it moving to production? So let's say, for example, a website is getting created. You as a person in the business team would be seeing the staging site, etc. But then you would be giving them the direction, okay, 30th of this month, this needs to kind of go into main production, right? And when it is going into production, perhaps there's going to be a downtime. There's going to be some time where people may not be able to access certain things, etc. Right? So how does that happen? So one needs to understand that from the developers, it goes to the main, and then from the main to the production. So so accordingly, as a business person, you will be keeping all these factors in mind, and making your business plans, right? So so hence it's important to understand this backend and the background.
The production server holds the code base and all compiled experience available to the end users. If you're using any application or website on any given day, you're using the production code on the production server. Having the main branch before the production branch is useful because sometimes things will pop up unexpectedly even after rigorous testing in the other stages. That way, changes can still be made before the next version of the app is sent to the end users via the production branch. It's important to note that not all companies or engineers use the exact same names and flows to eventually get their code to production. Sometimes the testing is done primarily in the main branch, and sometimes the flows will differ entirely. But let's recap the most important point here. There's usually several servers or branches that engineers use to check and test code to make sure everything's fine. One safe bet you can make, though, is that production code is always the live version, and main is always the step right before that's used for final checks. When
All right. The last part of today's training is what we will learn about the mobile releases.
Desktop and mobile websites were the king of the jungle. Making changes to your website or web application was simple. If you had an existing site but then made some changes to add a few new features, users of the website would see those changes almost instantly when you upload that code to the server. Now, when the iPhone came along, Apple introduced an app store to make a larger profit, control their ecosystem, and protect users against malicious applications. It worked. Soon after, when Android came around via Google, they adopted the same model. On an app store, anything available to download to your phone has passed a series of tests and met a set of prerequisites. This ensures the apps there aren't going to ruin your phone or be otherwise malicious. On the upside, though, the App Store model ensures a high-quality selection of applications, and the revenue split generates a healthy profit for Apple and Google. On the downside, app stores mean that tech companies and developers that want to be included must follow strict guidelines, plus a manual human approval process before anyone can download it. This can take days or weeks, and the guidelines aren't always very simple. Even worse, any future change to your app goes through the same process. Then you must wait until your users download the update to your app. You can see how this might be troublesome if you accidentally released a buggy version and need to get the working version to your users as soon as possible. Knowing all of this, imagine how hard it is to orchestrate the process of 10, 20, or more developers and teams, all simultaneously making changes to the respective parts of an app in an effort to get them to the end user. If you have 5 teams of developers and designers working on separate areas of your application at slightly different paces, it's clear that having each team release a new version of the app in the store the moment they're done could cause problems. Potentially, each of the 5 teams could be done on different days of the week, leading to 5 new updates of that app in the App Store during that week, which is a poor outcome and really annoying to end users. This issue is solved organizationally in different ways at different companies, but one of the most popular methods is something often referred to as release trains. Here's how it works. In real life, trains run on a set schedule. If you want to get on one, you've got to be there before it leaves for its destination. In the mobile development world, the concept is the same, but instead of a train, it's a scheduled release date on the calendar for a new app version that's going to the App Store. The timing is set ahead of time. For example, every 2 weeks on Wednesday, the newest version is sent to the App Store. So if you have the same 5 teams working on features, whoever has their new features written, tested, and merged into the main code base by the next train departure day will have their features available to the public on that cycle. If any teams don't have their work completed in time, they just wait for the next train, and in doing so have extra time to ensure it's working without any bugs. This model works well because it stops users from being spammed by constant updates, allows for easier internal engineering planning, and most importantly, helps out stakeholders like the marketing team, enabling them to plan the promotions around a relatively rigid schedule of releases. So now you're up to date on modern mobile release practices. Use this knowledge in your day-to-day work, and I'm willing to bet you'll be increasing your organization's productivity a substantial amount.
All right, I'll stop presenting. Okay. Any questions on this so far? about the common terminologies that's to be used. The usual common terminologies of the technical, like, terms that's required to be used, when you're working in an organization, and that will help in your conversation with the product team. So, any questions? Okay. If you don't have any questions, I think that's fine. You can always refer back to this recording at a later stage, right? Kionix Karnataka team.
Yes, sir.
Yeah, I think we are done with today's session, and I also see that there are no questions. There's a chat message coming to me as well, so I think
Yes,
we are
sir.
good. So thank you, and we'll see again in the next class.
Thank you, sir.
Yeah, thank you.